When you look at the night sky, you're actually looking in the past. This is because light has a finite speed, and the light from objects which are really very far away, like the stars, takes some time to reach us on Earth. You are hence looking at their past. Hello and welcome everyone to another new video. I am another random guy, and in this video we will talk about stars, the basic objects in the universe, giving relevant and interesting information about them. So let's get into it. We all know what stars are. A star is an astronomical object which produces its own light through nuclear reaction and held together by its own gravity. There are many stars visible to us, the closest being our own sun. Approximately, there are about 10 to the power 22 to 10 to the power 24 stars which we can observe from Earth. Well, most of the stars are actually invisible from where we see them, so imagine how many stars there actually might be in existence. It is said that the number of stars in the universe is more than all the tiny grains of sand present on our planet. No wonder we were taught in schools that stars are uncountable. Stars produce energy through a type of reaction called thermonuclear fusion, in which hydrogen is converted into helium in its core. Now let's discuss the life cycles of stars, how they are made and how they eventually die. This is going to be very interesting. An accumulation of gas, plasma and dust in a galaxy is called an interstellar cloud. A type of this cloud is called a molecular cloud, like a nebula, in which it is possible to form molecular hydrogen. These molecular clouds are the birthplaces of stars. They have high densities and low temperatures, and naturally, the gravitational force exceeds the internal forces. When it reaches a certain density, it satisfies what is called a gene's instability, resulting in its collapse. This begins the process of star formation. The process of collapse continues and the density of the cloud increases. The gravitational energy converts into heat and it becomes hotter and hotter until it reaches a point of stability called hydrostatic equilibrium, which forms the most basic star called a protostar. It derives its energy mostly from the conversion of gravitational energy. A star has a core in the center where its characteristics are the most extreme. In this protostar, the helium in the core and the nuclear fusion will eventually increase, resulting in the star becoming a main sequence star, and it will spend the majority of its lifetime in this phase. It will convert hydrogen into helium for a long time and thus emit energy. Our sun is currently a main sequence star and would live for approximately 10 billion years. The more massive a star is, the less time it would live. We now enter the post-main sequence stage of stars. Stars of low masses exhaust the supply of hydrogen at their core and start to fuse it in a shell surrounding the helium core. The outer layers of the star expand and cool down, and there is a considerable increase in their size. They become red giants. The core gets even smaller and hotter when almost no hydrogen is left, and a process called helium flash is started, in which helium is converted into heavier elements starting from carbon to oxygen. Eventually, all the helium is converted into carbon and oxygen, and the core collapses and enters a stage called the asymptotic giant branch. In this phase, the star will expand for one last time, ejecting all the outer layer into the external environment called a planetary nebula, which is apparently not related to a planet, leaving behind the core. The core cannot carry out any further reactions and gradually contracts and cools and becomes a white dwarf. The planetary nebula contains materials which would help in making new stars in the future. Also, a white dwarf fades into a black dwarf over a very, very long period of time. In case of massive stars, the initial stage is similar, but they will consume their fuel more rapidly. Hydrogen is converted into helium and eventually the star increases in size. When helium is almost finished, the core becomes hotter than the ones with lower masses and it is able to form carbon, oxygen, neon, silicon and then iron. When it produces iron, no net energy is released, and eventually the iron core becomes so large that it collapses. Electrons are driven into protons, forming neutrons, neutrinos, and gamma rays. The resulting shockwave results in the star exploding in a supernova. The supernova explosion removes the outer layers of the star, leaving behind remnants such as the Crab Nebula, and the core of the star becomes a neutron star, or if it is massive enough, a black hole. So this is the lifetime of a star, which is truly spectacular. We can say that they live no ordinary lives indeed. Stars are classified on the basis of the spectral characteristics. Electromagnetic radiation from a star is analyzed by splitting it with a prism or diffraction grating into a spectrum showing the rainbow of colors interspersed with spectral lines. The current system of stellar classification based on spectral analysis is called the Morgan-Keenan system. in which the letters O, B, A, F, G, K, and M are used, which tell us the surface temperature of the star, the hottest being O and the coolest being M, along with a number from 0 to 9, with 0 the hottest and 9 the coolest. Our luminosity class is added using Roman numerals, which actually tells us about the size of the star. For example, the full spectral class of the Sun is G2V, in which G2 tells us that its surface temperature is around 5800 Kelvin, and the 5 tells us that it is a main sequence star. So this was the basics of stellar knowledge that you needed to know. Every object in the universe, including the universe itself, is amazing and always worth exploring about. Thank you for watching. If you like this video, please subscribe to my channel for more interesting content like this. I will see you all soon.